everyone, welcome to my talk. Today I would like to talk about mobile performance, and more specifically I would like to share my experience of improving the startup performance of Turo Android app. However, all the tips and tricks and suggestions shared in this talk are totally applicable to any Android app. So if you're considering to improve the performance of your apps, I'm sure you'll find this talk useful. My name is Pavlo. I'm a Google developer expert for Android and Kotlin, and I also work as a senior staff engineer at Turo, where I mostly work on mobile performance, build performance, and also architecture. And prior to that, I worked on mobile infrastructure team at Lyft, where I was doing pretty much the same thing. So what is startup? Since we are talking about this topic, I think it would be a good idea to define what it actually means, because it's not as straightforward as one might think. In fact, there are different types of startup on Android, and the most straightforward one is a cold startup, which means that you don't have any Android application, your application running on the device, and you're just clicking on the application icon and the application is started. It's the most time-consuming type of startup because it needs to initialize all the components for your application process and then your components in your application itself. This is the most time-consuming and resource-consuming type of startup. However, there is another type of startup called warm startup. It happens when you already have application running in the background, and for some reason you collapse the app, you're doing some other stuff on your device, and then you click on the application icon again. In this case, Android operating system will not completely initialize your application because the process already exists. However, it will do some initialization of some specific components. So technically, this type of startup is a bit faster than the cold startup. And finally, there is a hot startup, which is pretty much the same as warm startup with one difference. So again, you have application running in the background, but this time when you want to open it again, you don't click on the application icon, but you just restore it from the recent applications on your phone. In this case, operating system does not initialize anything for your app, and it just brings the app to foreground, which means that this is the fastest type of startup. In the context of this talk, we're going to talk about improving the cold startup. However, when you do it, you will also automatically improve the warm startup, for example, because they share a lot of common components. And on this slide, you can see how the startup time of Turo app was improved by 77%. And in this talk, we're going to take a deeper look about how it was done. Right, to understand how to improve the startup, I think it's important for us to understand what components and what steps it consists of. So if taking a look at the startup process of Turo Android app, there are a bunch of steps. So first of them, when you click on the application icon, what happens is that Android operating system shows so-called a system splash. It means that you have a black or white background and you see application logo, and behind the things, Android operating system creates application process for you and does all the initialization. And for the most part, developers have a very little control of this process, and the actual developer's code is being run only at the end of this. Next, in case of Turo Android app, there was shown a custom splash, which means that this was already an application screen. It was run by developers, but it looks the same, right? You have a black or white background and application logo. What happened behind the scenes is that the application was running network requests, which are required to show the right content on the home screen. So basically, home screen was not able to be displayed before those requests are completed. Also, we were running the animation, which was taking around 1 second. So it's a pretty debatable topic whether you should run animations on startup or not, but it was added there a long time ago, and it was part of the design language because, as you can see, the application logo is moving, and Turo is all about vehicles, and vehicles tend to be in movement. So yeah, you get the idea. That was the point. But then we decided just to remove this animation just to not waste users' time every time they launch the application. And finally, when all the splash work is completed, the user would see the home screen, and optionally there will be a loading state where all the data for the home screen would be fetched. All right, so now that we have an understanding of what the startup process consists of, let's see how it was improved. First, and the most obvious thing to improve was improving the splash screen. And as you can see, if going back to all those steps, the 3 or 4 steps during the application startup, they were all about splash, and they were somehow related to that. And if taking deeper into the implementation, usually the old practice and the old pattern on many Android applications is that you have a separate splash activity. And for non-Android folks, activity is kind of a class representation of a screen. It's a very rough analogy, but it will work in this context. And only then, when all the splash work was completed, the user will see a home screen in a separate home activity, which means that we would need to instantiate 2 activities and do a bunch of extra work. And also, all this process in code was not very intuitive. So yeah, there is a space for improvement here. Luckily, Google released a new API called Splash Screen API, which allows to significantly simplify this process. In order to set it up, just open your root activity of the application, and in the onCreate function, you can do a setup by using install splash screen. And optionally, if you want to control the duration of the splash screen, if you want to prolong it for some time, you can use the set keep on screen condition callback, where you will define explicitly when should you close the splash screen. So after the integration, as you can see, the number of steps significantly decreased. And moreover, all of this is happening in the same home activity, which means that we are avoiding a bunch of allocations and making the process more intuitive, which already a good improvement. Right. Next thing that we improved were network requests. And in particularly, the suggestion here will be the following. Do not perform blocking network requests during startup. And I would say under any circumstances, because in our case, network requests were done and performed and when this was happening, the user would see a loading screen and they would not see the home screen. However, in most cases, even if you think that it's not possible to defer the network request, most likely it's possible to find the workaround, which we did as well. So all network requests now are running in the background and they are not impacting the startup of the application. Next, very important topic is disk I/O. And I would say this is usually the top contributor to startup time of any Android app. So I would, if you are considering to improve the startup performance of your app, I would consider starting with this topic. It usually includes disk reads and writes on the UI thread, and using some tools like databases, Room, Realm, etc., shared preferences, data store, and stuff like that. All those libraries that I used for disk I/O. And the general suggestion here is that it's better not to perform disk I/O on the UI thread, where the UI of the application is being rendered. And moreover, it's not recommended to perform disk I/O before the first UI frame of the application is displayed. So even if the disk read operation is running in the background, it's a good idea just to postpone it after the startup, because the duration between you click on the application icon and you see the app, it's the most critical time in your application lifecycle, and we want to make it as fast as possible. And okay, we know that disk I/O is on UI thread is a bad thing, but how do we detect it? And luckily, again, there is a SDK for it, an API for that, which is called strict mode. So it's part of Android SDK, and it allows to detect some wrong operations on the UI thread. And in order to set it up, you just go to the application class of your app. In the onCreate function, make sure you're using it only in the debug mode. We don't want to have it in production builds. And then there's a pretty simple setup. Which consists of 2 parts. So first, you just tell the strict mode what it should detect. And in this case, we are telling okay, detect disk reads and disk writes, because there are some other operations that it might detect. And finally, you need to tell strict mode how should you be notified if anything happens. So in this case, we're using log, which will put some logs in logcat. And also, you would see some flashing screen, like a red frame around your screen. And that's why we shouldn't do it on production builds, but this is a helpful tool for us to detect any issues. And when it happens, when some violation happens, you will see logs. and you will see strict mode policy violation. You will see the duration, how much it takes, and which policy exactly was violated. In this case, it's disk read violation. And also, it's pretty convenient that you will see a link to the line of code which is coding that, which is pretty convenient to fix that. And yeah, it looks pretty simple, right? You just need to go through logs and check every instance of a violation and just make a fix. However, sometimes there are edge cases which are not as straightforward as in general, right? Okay, before we proceed here, we need to make a step back and take a deeper look in the Turo Android application, because there are two modes of the application that you can use. So as a guest, you would book vehicles, to use them. But as a host, for example, you would list your vehicles for others to book. And as you can see, those modes have different home screens and they look completely different. However, this is still the same application, right? And you need to decide somehow on startup what home screen to render. And going back to disk IOs, right? When you feel like you need to perform a disk IO on startup, you should ask yourself a question. So when I read this value, should this value be used before the first UI frame is rendered? And in other words, is the first UI frame of the app which is rendered, does it depend on the value of the value that you just read from the disk? If no, just simply defer the request and read the value on the background thread. However, if yes, this is the case with our home screen, because right before rendering any frames of home screen, we need to decide what type of screen we should render. So in this case, it's recommended to use shared preferences, because this is like the simple and straightforward way to read key value pairs from disk. And it's also important to do it on UI thread. And why is that? Because when this is happening, the user is still seeing the splash screen. So there is no point of switching to the background thread, because thread switching still takes time, and we need to do it as fast as possible. Another important tool that helps to improve the startup is baseline profiles and also startup profiles. This is a toolkit released by Google recently that helps to improve the startup time of Android apps with a pretty low effort. So baseline profiles, what they allow you to do is that they precompile ahead of time the code paths that are executed during the application startup. And startup profiles, they do pretty similar thing, but a bit different. They reshuffle the contents of DEX files of the application. So basically, DEX files, they hold all the source code, or like compiled source code of the application. And historically, usually large Android application, they consist of multiple DEX files. So what startup profiles do, they put all the startup code paths in a single DEX file, so that when your application is started, only one of them is used during startup. And how to use baseline profiles and startup profiles. I won't be diving into specifics in details, because the documentation covers pretty well, but the gist of it is that you create a macro benchmark, which is an instrumentation test that will record all methods, classes, and used during app startup. And then it will generate a txt file, which you just need to put into the right application. And when you build the application, it will have the baseline profiles inside. However, there is a problem with those tools. Baseline and startup profiles, they cannot speed up disk I/O, which means that no matter how fast your code is compiling, if you're using disk I/O operations on startup, they will significantly decrease the efficiency of startup and baseline profiles. That's why I mentioned that disk I/O is very important, and it's important to keep startup light and avoid those operations. And also, it's important when you use baseline and startup profiles to cover both code paths covered by feature flags, if you are using feature flags on application startup, because these are two different branches that cover different paths of code, and all of them should be present in startup and baseline profile configurations. Another important thing is application lifecycle callbacks. So these are callbacks that allow you to hook into the lifecycle of different screens, like activities or fragments, and especially those that happen on the start, because when you open your first activity and when you have those callbacks with heavy logic, they will also slow down the startup. Similarly to uh, the same works for fragment callbacks, especially those again that are run on the start of the screen. So it's important to keep the code of those callbacks pretty light and avoid any heavy UI operations there. And one important topic is third-party SDKs. And why is that? Because they can perform disk IOs operations on UI thread, and they can use app lifecycle callbacks implicitly. So when you use any third-party libraries, it's important to check their source code and make sure they do not slow down your app startup. And luckily, strict mode can help with that also, because it detects errors in third-party libraries. And yeah, it's better to initialize third-party libraries as late as possible. So let's conclude. I think it's important when working on performance is to keep balance between the effort and the impact, because we don't have all time in the world. We usually have some other work that we need to do, and it's important to prioritize improvements that bring the highest impact but also require lowest effort, especially if you are not part of the infrastructure team and if you're working on some product team and this is your side project. You need to make sure that you spend reasonable amount of time and you have something to demonstrate, so that you can gain more resources to do this job in future and do some other performance improvements. And one more important thing is to know when to stop, because usually you can work on performance improvements infinitely because there is always space for improvements. However, it's important to know that if your efforts bring only like 1% improvement or 2% improvement, but they require you to rewrite the entire home screen logic, do some critical changes that might break application, and decrease the user's experience in other stability areas, it's better to stop and already have evaluate already improvements that you already gained with those low-hanging fruits, and then evaluate what you should improve in the application next. So all right, that's it from me. Thank you for watching this talk. Please feel free to connect on the social medias, and yeah, thank you for watching.